All right, here we go. Let's try some other integrals. So on e, if you notice the derivative of the denominator is not on the top, and this doesn't fit any of the other formats either. So are going to have to be a little creative in how we do this. So it is kind of close to an arctangent form. It's just a little bit off. So we're going to force it to fit. So I'm going to complete the square in the denominator. So for the x squared plus 4x, to complete it, I need a 4. Well, I had a 13, so if I take 4 from the 13, I have 9 left over. So now I can factor those x's. And there we go. We have the format we want. So that will be 1 over 3 arctangent of x plus 2 over 3 plus c. So if it's close to an arctangent, you can always complete the square. And in fact, that's what we're going to need to do in example F, because it's close to that arcsine, but we need to complete the square in order to do it. So first off, let's pull that 2 just out to the front. And I'm going to factor a negative out, because when I complete the square, I want my x squared term to be positive. So what number would complete the square inside of the parentheses? That would have to be a 4. Well, I can't just throw a 4 in there and nothing else. I have to put another 4 over here so that they'd actually cancel out. Now, normally you would have them opposite in sign, but in this case they really are, because remember, this negative is sitting out in front of this quantity, so that 4 that we stuck in the parentheses is really a negative. So I have root 4 minus x minus 2 squared, and that'll give me the format I want for my arcsine. Okay. All right, these next 4 examples, these are just kind of ones that are going to be all over the place, because again, you need to know what to choose from and what techniques to work or to try at the right time. So for example G, this just fits really nicely in arctangent. So 1/2 arctangent of x over 2 plus c. Well, this next integral, it's really similar. It just has an x instead of a 1. Well, that's now going to change it, because this is no longer an arctangent, but you have a fraction, so is the derivative of the denominator on top, and it is. You just need a 2 and a 1/2. So this one is actually 1/2 ln of 4 plus x squared, and I do not need absolute value bars, because 4 plus x squared is always positive. Okay, now this one down here, it is close to an arcsine, but you have this x that messes it up. It's no longer u prime on top. So this one actually is a u substitution. You just need a -2 inside and a -1/2 outside. So our integral becomes -1/2 times integral of 1 over root u du. So you're really integrating u to the -1/2. So if you integrate that, that is 2u to the 1/2 plus c, and then switch it back in terms of x. And then I'll change the 1/2 exponent into a radical. Okay, so that's how you would do that one. And now this one over here, that one actually is the Arcsine format that we want, because now you do have u prime sitting on top. So this is just arcsine of x over 5 plus c. All right, so we will continue on in the next video, so stay tuned.